Our laboratory, the Visual Optics and Biophotonics Lab of the Institute of Optics, started in 2000, and since then we have been developing research that combines physical and technological approaches. We have developed equipment, we have tackled interesting questions in refractive surgery and cataract surgery. So in a sense, proposing the developments of presbyopia correction alternatives is a result from years of experience and work. The European Research Council has just awarded a project entitled Bio-inspired optical corrections of presbyopia. It is a project for 5 years that will allow us to investigate the basic mechanisms for pixel perception, for the crystalline lens mechanisms. There were about 15 people involved in the project with various backgrounds. And also we will have collaborations with polymer scientists, with mechanical engineers. The instruments that we have developed in our laboratory range from techniques to measure the optical imperfections of the eye, techniques to measure the geometry of the cornea and the crystalline lens, techniques to understand the optical structures of these ocular components. And also we have developed techniques that aim at comparing visual quality with visual function in the eye. The ultimate aim is to understand visual quality and actually improve vision in the patient. We can provide models that are based on the optics, but also on the biomechanics of the different structures. But of course, we have also tested these instruments in patients. Presbyopia is an ocular condition that occurs with aging. It is the failure of the crystalline lens of the eye to accommodate to near and far objects. It affects everybody after the age of 45, and it is estimated that about 209 million people in Europe are affected by presbyopia. This is about 44% of the population in Europe, and about 22% of the active population. The young eye has a crystalline lens that is flexible and that can accommodate and reshape upon an accommodative stimulus, so it can really focus near and far. However, with age, the crystalline lens loses this ability to reshape under an accommodative stimulus, and therefore is no longer able to focus near and far objects. Today there are some attempts to correct presbyopia by lenses that move inside the eye. This is definitely a first step into the development of accommodative intraocular lenses, although they're still far from emulating what the crystalline lens in the young eye does. Presbyopia could be cured if we can replace the crystalline lens that has no longer the ability to accommodate with an intraocular lens that will have this ability. So these would be sophisticated lenses, and like the current lenses that are either monofocal or multifocal, and they have to rely on the rest of the accommodative plant working, and particularly they have to be flexible and sophisticated enough to really mimic the young crystalline lens in the eye. The project is very challenging. It covers various parts that includes technological developments, groundbreaking research on aspects of the visual system, as well as developing Eventually, an intraocular lens that can be implanted in millions of people to correct for presbyopia. The research is structured in 3 different areas. So a major area goes around the development of technologies. There is a second stage where these technologies will be used to understand those mechanisms, so by measuring patients and animal models. And there is a third stage where we will be aiming at new designs of multifocal corrections as well as accommodative intraocular lenses. It's a really great opportunity to being able to work towards such a problem, to correcting presbyopia. It's great to be able to work every day with an enthusiastic group of people and to be every day a bit closer to the solution.